Okay, let's dive right into this. Welcome to This Explainer. Today, we're unpacking a really incredible one-year extracurricular roadmap that's totally designed to build future-ready tech skills. And, we aren't just talking about your standard basic computer class here. No way. We're looking at a massive, comprehensive journey. We're going to take you from the raw physical wiring of microchips straight into building digital 3D multiplayer worlds, and finally, all the way to the absolute cutting-edge frontier of AI-assisted software development. So if you're wondering how tech education is evolving literally right now, you are exactly in the right place.
So here's our game plan for this journey. Section 1 covers physical computing with the ESP32. Section 2 moves us into digital worlds through Roblox. And Section 3 explores the AI-assisted future, which is also known as vibe coding. Let's get into it.
Now, what's genuinely fascinating here is the progression. This timeline isn't just some random assortment of classes thrown together. It's highly intentional. We're going to see how this curriculum moves from grounding logic in tangible, touchable hardware up to complex software, and finally upward into AI abstraction. It's like a giant puzzle where each phase strictly builds on the foundational logic of the last one. So, trimester 1. You get your hands dirty with physical and Internet of Things projects. You actually see your code move stuff in the real world. Once you nail that raw logic, trimester 2 scales it way up into digital logic inside simulated environments. And then finally in trimester 3, since you're armed with a really deep understanding of how systems actually work under the hood, you are fully ready for vibe coding.
All right, trimester 1, physical computing and IoT. Let's start right at the beginning.
To really wrap our heads around physical computing, we gotta look at the ESP32 ecosystem. And the easiest way to do that is with a brain input-output analogy. First up, we have the brain. That's the ESP32 microchip itself. This processor is lightning fast, it's got built-in Wi-Fi and Bluetooth, making it absolutely perfect for IoT projects. And here is a mind-blowing little fact for you. This entire brain usually costs less than a fancy cup of coffee. Crazy, right? Second, we have the inputs. These are sensors reading the physical world, like the DHT11 for temperature or the HCSR04 for distance. And finally, the outputs, or actuators. These are the pieces that actually do the physical work based on the data, like lighting up LEDs, spinning little servo motors, or turning on mini water pumps. Okay, so how do we actually tell this little brain what to do? Take a look at this logic flow for Arduino coding. It basically always boils down to two foundational steps. Step 1 is the void setup function. This runs exactly one time the second you turn the ESP32 on. It's where you define your pins, basically telling the chip, hey, pin 34 is an input sensor, and pin 25 is an output actuator. Then, step 2 is the void loop. This right here is the heartbeat of your program. It runs continuously, over and over in a never-ending cycle, to read the sensor data, run that data through your logical if-else statements, and finally command the actuators to act. Let's ground this with a real-world example so you can see how it all comes together. Imagine you're building an automated plant waterer. Your ESP32 loop is just constantly reading analog data from a soil moisture sensor. And analog data is really just a continuous range of numbers. So let's say a reading of 0 means soaking wet, and 4095 means bone dry. Your logic says, okay, if the soil moisture value is greater than 2500, the soil is getting dry. The ESP32 processes that thought, sends a high signal, which basically just turns the power on, so your plant doesn't dry up and die. The water pump kicks on. Then, once the soil gets wet and that sensor reading drops, the loop runs again, hits your else statement, and sends a low signal to cut the power and turn the pump off. You are literally bringing logic to life. Moving right along. Trimester 2, Digital Logic and Roblox Studio. Okay, so now that we've totally mastered grounding logic in physical hardware, we're shifting the energy up, removing from physical wires into giving life to digital 3D worlds. Now, in Roblox Studio, the visual design, the 3D modeling, that just creates the shape of the world. But to make it an actual game, we need code. And that brings us to Luau. Luau is a lightweight, super fast programming language derived from Lua, and it's custom optimized by Roblox. Think of it this way. Without Luau, your beautiful 3D assets in Roblox are really just lifeless decorations. Luau is the magic that calculates the leaderboards, triggers those secret doors when you walk by, and programs the enemy characters to actually chase you. And this setup brilliantly illustrates how complex multiplayer systems are organized under the hood. When you're coding in the Roblox Creator Dashboard, you essentially juggle 3 core script types to keep the game perfectly synced and completely tidy. First is the server script. This runs on the main Roblox server and handles the global logic that absolutely must be identical for everyone playing, like saving player data or spawning enemies. Second, you have the local script. This one runs directly on your personal device, managing your specific screen's user interface and your keyboard inputs. And finally, module scripts. These act as storage for reusable code, making sure your main logic stays clean and doesn't get totally cluttered up with repetitive lines. Now, you might be wondering, why choose Roblox for this second trimester? Well, first off, it uses very simple English syntax, words like if, then, else, while, and function. That makes it incredibly friendly for beginners who are just starting to learn computer science. Second, it gives you instant live testing. You literally write a script, hit one button in the simulator, and boom, you see your trap or your coin system work right then and there. But honestly, here is the real kicker. Monetization. Skilled creators can sell in-game items or access passes for Robux, and through the Developer Exchange or DevX program, you can actually cash those Robux out into real-world money. Seriously, through DevX, some teenage developers are literally making millions of dollars. It's a real game changer because it connects learning directly to tangible, real-world value. All right, trimester 3, the AI-assisted future, with a specific focus on vibe coding. We've built our fundamental skills. Now it's time to put the pedal to the metal. Take a look at this quote. The term vibe coding was popularized by the famous AI researcher Andrej Karpathy back in early 2025. Basically, vibe coding is a whole new practice where humans don't write lines of code manually anymore. Instead, we act as directors, giving instructions through natural, everyday language prompts. It's a complete paradigm shift. You, the human, get to focus entirely on the ideas, the business logic, the overall architecture. You focus on the vibe or the direction. Meanwhile, the AI acts as your builder. It handles all the tedious typing, finds the errors, and executes the actual deployment. So, the workflow of vibe coding is essentially this blazing fast feedback loop. Step 1 is the idea description. You give the AI a high-level prompt like, hey, build a web-based employee attendance system with facial recognition. Step 2 is auto-code generation. The AI tools instantly translate that prompt into a full file structure, a user interface, and all the back-end logic. Step 3 is test and review, where you just run the app to see if it matches your vision. And finally, step 4, iterate and fix. If a button is the wrong color, or say there's a bug when saving data, you simply chat with the AI again. You just say, change the button to blue and fix the save error. This whole process turns your raw ideas into a minimum viable product, or MVP, in literally minutes instead of weeks. It's wild. Now, let's contrast these two approaches for a second. Manual coding, which is exactly what we did in trimesters 1 and 2, is definitely slower, for sure. But it actively builds your core logic muscles. Vibe coding, over here on the right, gives you super fast prototyping. It frees developers from typing out repetitive boilerplate code. You know, the boring setup stuff you have to write over and over just to get a project off the ground. However, and this is absolutely crucial, it requires supervision. While vibe coding makes software creation incredibly accessible and inclusive for non-programmers, there is a catch. Which brings us to section 4, why fundamentals still matter. So with AI doing so much of the heavy lifting, you're probably asking, why didn't we just start our extracurricular year right here with vibe coding? Well, tech educators warn of a few massive risks if you skip straight to the AI phase. First up is the illusion of competence. Beginners who rely solely on AI might feel like expert developers, but underneath it all, their foundational coding logic just hasn't been built. Second, you run into huge security and scalability vulnerabilities. AI often generates code that looks fine on the surface, but it might be prone to data leaks, or maybe it isn't optimized for large transactions, or it completely fails when integrated into complex infrastructure. Which leads us to point 3, the most important one. You absolutely need a human supervisor. Without those logic muscles you spent trimesters 1 and 2 building, learning about inputs, outputs, server syncs, and loops, you simply cannot effectively read, audit, or secure the complex code that the AI is spitting out. Basically, you have to know the rules to direct the machine. And that wraps up our explainer of this incredible 1-year extracurricular roadmap. You start by physically manipulating the real world with the ESP32, then you scale those logic skills up to build digital multiplayer realms in Roblox, and finally, you completely supercharge your output by directing AI through vibe coding, all while holding on to that crucial ability to supervise the machine. It really is a powerful, future-proof sequence. So I'll leave you with this final thought. Now that you understand the tools and the roadmap, what project will you build first?